RC Jim, and today I want to walk you through some of the things that I've been doing to this Hangar 9 P-51 that I acquired recently from a club member. It started out as a nitro plane, obviously, with a big hole here. It's been converted to electric. The other fellow used to run it on a 5S battery. I don't use 5S batteries. I use 4S and 6S and don't particularly want to add another size. So the motor is good. It's a Dualsky XM5050EA-12, I believe it is. That's good for running on 6S. And so I'm going through a great variety of things, and we'll walk through each of them with you on the video. Number of issues that I found with the plane that didn't keep it from flying, but I felt that they needed to be rectified. And yeah, so we'll just show you the various issues that we ran across and how we worked through them. Well, as we think about the various issues that we had to work through, first had to do the wiring. The ESC, as you can see there, has had a fair bit of damage, plastic missing on part of it, bubble up around it and so forth. Back in the plane itself, it was all XT60 connections, and of course that's an 80 amp ESC. And in our testing we got up to 84 amps with the current setup, which is too much, but nonetheless I wasn't real happy with just simply 60 amp connectors. Furthermore, it had a plug on the side of it to disarm the electrical system, which in theory is a nice idea, but it just adds more connections in there. And so we had jumpers and connections all over the place. So I wanted to simplify all of that, reduce some of the jumpers that were in there, get the ESC sorted out, and make sure that we had the system running as efficiently as possible. Now, the other thing having to do with the ESC had to do with how it was mounted in there. Had a aluminium, so like a flashing material that had been used to hold it down. There you see it bent over as I'm trying to get it out. But it had been attached to that little piece of plywood before the plywood was glued in, and then it was glued in with epoxy. So I was able to get a couple of the screws out through the back there. And then on the front here, I had to get some pliers in there, some needle nose vice grips, to get a hold of it and just turn it a few degrees at a time to work those last two screws out. But we were able to do that, and finally got that compartment nice and clear to where we could properly fasten the ESC in there with some Velcro. The next issue that we had was the battery compartment. The previous guy had used a 5S battery, and he had it right in the middle of where that black strap is. But he also had three huge lead weights up front. So I was going to a heavier battery, and I didn't want that extra weight of the lead weights. So I wanted to position the battery all the way forward, or up in that area anyway. So I added these rails in there to hold it side to side, added some Velcro farther up in there. And then worked out how we can basically kind of wedge it in there, as you'll see in a minute. And that's worked out well. So here we have the 6S battery going in. We sort of hold it up near the top of that compartment to get it past the Velcro until it gets up all the way to the end. And on the end of it, I do have a little pad there to protect it from abrasion on anything on the firewall. So get it all the way up in there. The strap isn't the main thing that holds it in, but rather we got this little block of balsa with some pads that I've put underneath it. And that wedges in between the top of the battery and the two bulkheads that are over top of the battery. So you just slide that in up to the stop, and that's pretty snug in there, so that stays put. And then the straps are fastened across the back of the battery to basically just be some extra insurance to make sure it doesn't slide out going backwards. And so I strap those across there, so there's not really any significant distance that battery can go anywhere. And I reckon that's pretty safe. We were now ready to get started reinstalling the ESC, and so I've disconnected it from the motor. Had had those extra jumpers in there that I wanted to get rid of, and actually had to change the banana connector, had to desolder it from the jumper and put it onto the ESC lead because they were different size, and actually the jumper introduced a lower capacity connector than what we wanted anyway. So I got rid of the jumper, had the right connectors in there, and then we're ready to get the ESC in place. In getting ready to place the ESC, we had to work out what was going to fit where. We verified that we didn't need the extensions on the wires that'd be adequate to go directly to the wires on the ESC. Then we had a look at where the wires were going to come through the other end. We could almost get by without that extension there, but we had an issue with that XT60 connector being the size that was needed to fit through the bulkhead, and the XT90 that we'd want to use on there being too big. And then it would just be pretty tight. I'd have to do the soldering down inside there. So I decided to retain that extension on the end there. So we're getting ready to pull it through. When I'd pulled out the ESC, I'd run a string through the plane there to make it easy to pull it back through. So I just taped the string onto the end of the wires there, pull them through to be able to get everything in place. And then after it was pulled through, then I removed that extension to be able to solder on the new connector. Before putting the ESC back in, I decided to tape up some of the areas that were exposed, in particular where there was parts of the circuit that could potentially short out on something. Never know what screw might drop in there or something like that. So those areas were taped off. Then I decided to use the heat sink area, since it was flat, to stick on the Velcro. And then realized there's a bump next to it, so I had to use some double stick tape, foam tape that was thicker, to bring it out far enough to where the bump didn't interfere with it being able to be stuck down. The next thing that we did was to check out the motor and ESC and so forth as to what sort of current it would be drawing and what sort of thrust it would generate. So this is our test rig. We got a little scale there to measure the thrust attached onto a solid set of posts that we put in there, have it propped up to where it's not dangling down, can pull it straight. And it gives us a digital readout, and it actually remembers the maximum thrust that it gets to. Got that little yoke to attach to the tail. And of course the plane is free to move forward and backward. We've got a variety of safety things in place. So anyway, as you're looking at that, as far as the results went, with the prop that was on there from the previous owner, it was a 3-bladed 13x7, that one that you see there with the rounded tips and so forth. With that one, it was drawing 74 amps at full throttle, developing just under 1,500 watts and 4,200 grams of thrust. This, however, was just a little bit more than what was recommended for the maximum 15-second burst, 70 amps that you see there in the left-hand column for this particular motor. And so I decided to get a master air screw 12x6 3-bladed prop, and we gave that a go. We did that. We actually reduced the amps a little bit, as expected for a smaller prop, but it actually increased the thrust, 4,405 grams, as you see here. After running those tests, the penny dropped for me, and I realized that I really should be running the battery fully charged to get the maximum current draw. So I redid the test with a fully charged battery. So we went through that again, started by recalibrating the ESC, checking the programming on it, everything was okay there, utilizing the fully charged battery, ran the test, found that we had an increase across the board, not surprisingly. What is interesting is that while the voltage increased by 11%, the thrust also increased by about 11%, but the amperage was double. 22% increase. So imagine something exponential is going on there. While we're on the technical bits, I note that the recommendation using a 6S could go up to a 14x6 electric prop. And I would think a 12x6 3-bladed wouldn't be any harder to spin around than that particular one. So it's a bit shocking that something that's going to generate or require 84 amps of current is within the realm of what's being recommended. But I do note that their 14x6E prop that they recommend does go beyond what they say is the maximum. If you look at the white line there, at about 1400 watts is where it makes a transition between the black and the brown background. That's their maximum. And by the way, on their key, they say electric power is in 5 watts. It's actually in 10 watts. But anyway, that white line crosses the border between the black and the brown at 1400, which is the maximum watts, which is just below that 70 amps that you see in the bottom scale. So if they're using a 14x6, they clearly don't want to use top throttle for 15 seconds. Top throttle would only be used for a few seconds and very sparingly. So I guess I'm in the same category as that. Nevertheless, while I flew it that way today very carefully, I do have a 12x6 2-bladed prop on order, and we'll do some testing with that as well. Okay, we're getting our P-51 ready to fly, and this is perhaps a continuation of the topic, what's wrong? Now notice this aileron servo here, how far the servo arm is out from the plane as compared to the one over there. This one is sticking up way higher than that one. That means that the other aileron is going to have more movement on it than this one. So yeah, the plane will fly, but that's not exactly ideal. One other thing that has got me wondering a bit. Of course, this used to be a glow fuel powered plane, so they have the big hole here for that. So that's going to allow some air to get in there. But apart from that, all you would have is this little tiny air intake here. That is not going to be enough to cool that motor. So if it wasn't for this great big hole here, I think I'd be running it without a spinner, allowing the air to go in past the prop in the front of it, just to provide cooling. And even as it is, the hole to go back through the plane is here at the bottom, up in this area. So yeah, that is sort of shooting straight at it, but that's not a lot of air. I imagine the air will swirl around and it'll get in there, especially if it's got a good exit point. And of course, the fellow that did do the conversion on this did provide for an air exit back here. So that's good that he did that. So that was an area of concern, but flying it today, of course I was careful of the throttle and all of that, but after each flight I did stick my finger there and felt the temperature of the motor case as well as the shaft in the middle of the motor, and each situation it was just mildly more warm, not hot enough to burn my finger, and the battery was only very mildly warm, so all looks like it's pretty good. Of course, prior to flying the plane, we needed to work out the balance. For our weight and balance, we're going to have it set on these with, of course, the plane upside down. Previous owners put these marks on there, which are roughly what the manufacturers recommended. In this case, 95 millimeters back from the front of the leading edge at the root of the wing. As in my previous weight and balance video, I do find that very suspect in that they're basing the balance point on the root of the wing when this wing very rapidly skinnies down. And if you think about where this would come in, if it didn't have this little section right here, this wing would come in to back about there. So I reckon someplace between those points and probably closer to this one is where you ought to reckon that the front of the wing is, and then work on 25% back from that. But nonetheless, by my reckoning, just behind that, within a couple of millimeters behind that, is roughly where I think it ought to be. So we get this turned over carefully. Okay, so with the plane in place, I'll then put one stand under one wing and then put the other stand under the other wing. And they're set to have the plane a little bit higher than where it's presently at. And we'll adjust these as we go, forward and back. You note that these stands are made to where it can wiggle one way or the other, which will allow it to conform to the wing. Okay, now the next thing I'm going to do is just make sure I got it lined up with my stand to give us some clearance. Okay, so right now we're slightly nose down, but we want to position these things a little bit better. We want the stand perpendicular to the fuselage. Get it most accurate position. Okay, now that's right on the back edge of that mark. That's a little bit tail heavy. And this is going to be a very fine adjustment. You can see already we balance right there with just moving one back about 1 millimeter. I suppose this one's already roughly there. Okay, I'd say that is about 5 millimeters back from the middle of those marks that were on there. They are now nice and evenly balanced, and I'm very happy with that. And that makes sense because I'm doing this today. I actually had the remade in flight with it today, and it flew beautifully. So not surprising that that balance works out well. Now into the mysteries of flight. The P-51 flew on a remade in flight today, the first flight after doing all the modifications to it. And as you can see here from the setup, I've got right trim on the aileron and right trim on the rudder. Now, I did a lateral balance on the plane. I put the end of the rudder onto the surface of the boat here, held it by the prop, which is free to turn either way, and it was perfectly balanced. No problem at all, right to left in terms of lateral balance. So then I thought, well, maybe that big hole where the engine used to be, maybe that's what's causing the problem. But as I thought about that, it seems like if the air got caught in there, isn't that going to pull it to the right? And so I need to add left trim. But what I'm having to do is to add right trim. Looking at the control surfaces with the trim added, the ailerons are definitely deflected. Rudder looks pretty straight. The bottom line is this is one of those great mysteries of aviation. So if you got any ideas, hey, drop them into the comments section below. We could all maybe learn something. Well, I trust that this has been helpful to you as we've worked through these matters in this plane. As I said, we flew it today and enjoyed that very much. Very nice characteristics of, taking off and landing, and flying was fine. It's not any aerobatic star. You do rolls. It likes to do barrel rolls rather than nice straight rolls. But nonetheless, a joy to fly, and it's been well worthwhile getting it all trimmed up and ready to go. Well, thank you for watching today's video. We try to produce a lot of helpful information. Yeah, include some crazy ideas and some really good tips. All of it I trust that you find to be quite interesting. So, subscribe to our channel. You see the link down here at the bottom. And as you do so, browse through our videos and you'll find a great deal of variety there. There'll be tips and tricks on how to do various things, such as what we've shown you today. There's flying demonstrations, there's tips on how to do the flying itself, as well as how to set up your transmitter and all kinds of stuff. So be a subscriber. We would appreciate it, and you'll benefit a lot from it. So this is RC Jim signing off. You have a great day and enjoy your flying.